Chapter 12 Sensors. In this video, I will be talking about Chapter 12 of the Starting Out with App Inventor for Android textbook. Chapter 12 focuses on the three types of sensors that are found in Android devices. The types of sensors are the location sensor, the orientation sensor, and the accelerometer sensor. The location sensor determines the device's physical location. The orientation sensor determines the device's orientation in 3D space, and the accelerometer sensor determines the device's acceleration in 3D space. All three of these sensors can be found in the sensors palette in the design editor, and they're all non-visible components. The location sensor. The first type of sensor is the location sensor, which is found in the sensors palette. It is a non-visible component that is used to determine a device's physical location. Location is usually provided on smartphones by the global latitude and longitude values and may include the physical address. There are three sources that the location sensor can use to get information. The sources are GPS, Wi-Fi, and cellular towers. A GPS uses satellite technology to get the location information, so the device must be outside and in line of sight of at least 3 satellites. If the device is in the proper line of sight, it can receive the latitude, longitude, and altitude of its location. If the device is connected to a Wi-Fi network, it may use the location information from the Wi-Fi router, so the actual longitude and latitude shown would be of the router. The device can also use cellular towers to determine its location. It does this by using the strength of the signals from the closest towers to the device. The strength of the signals are used to determine how far the device is from the towers, and this determines the location of the device. Sensors can be used in many different ways, such as in apps to store an address, to give alerts, and when the device is a certain distance from a place, to track your travels or to notify others of your location. Now I will be discussing the location sensor's properties. The first one is the enabled property. The enabled property must be selected to allow the sensor to work. To do this, click on Location Sensor in the Components section, then select Enabled in the Properties section. You can also program it in the blocks editor by setting the location sensor.enabled to true. Next are the latitude and longitude property blocks. These blocks hold the values of the latitude and longitude of the device's location. There are also the has longitude latitude property blocks that are read-only properties as their value is determined by the device. If the has longitude latitude property is true, you will see the latitude and longitude values, and if it's false, you will not. It may be false if the device is unable to show location values or if location services are turned off. Next are the altitude blocks. They hold the altitude of the device. The location sensor provides a Boolean has altitude property, so the has altitude property will be true if the device is able to report the altitude and false if it can't. This is also a read-only property as its value is determined by the device. Next are the accuracy blocks. They hold the level of accuracy of the device's location information in meters. There is a corresponding Boolean has accuracy property which is used to check if the device is able to report accuracy. It will be true or false based on the device's capability, and accuracy blocks are also a read-only property as the value is determined by the device. There are also distance interval blocks. You can use the distance interval property to set the location sensor to update location information after the device has moved a certain distance. The interval is measured in meters. For example, if the interval was set to 10, location information would be updated when the device moves at least 10 meters from the previous update location. This property does not update at every 10-meter distance exactly. It only indicates that the location will not update before a 10-meter distance. You can also set this property at design time by clicking Location Sensor in the Components section and then setting your desired distance interval in the Properties section. You can also set these intervals to update at a certain time by using the time interval blocks. This property allows you to set the minimum time interval between updates in milliseconds. For example, if you set the time interval property to 600,000, it will mean that the device will wait 10 minutes before another update because 1000 milliseconds equals 1 second. However, just like the distance interval property, when you use the time interval property, it doesn't mean that the update will occur every 10 minutes. It only indicates that it will not update until 10 minutes have passed since the previous update. You can also set this property at design time by clicking Location Sensor in the Components section and then setting your desired time interval in the Properties section. The next property is the current address block. This property gives the current physical street address in text, and the address is provided by Google Maps. This is a read-only property because it's set by Google Maps and it's based on the current location of the device. The location sensor's methods are latitude from address and longitude from address. They both relate to the sensor's geocoding abilities. Geocoding is the ability to take an address and use it to determine the latitude and longitude values. So if you enter an address, it will return the latitude and longitude values of it. Note that the latitude from address and longitude from address methods cannot be in an initialization block. Last is the location sensor's location changed event handler. This event executes when the app initially starts and each time the device reports a new location. The values for the latitude, longitude, and altitude can be accessed by hovering your mouse over the parameter names on the event handler block. This event handler updates the labels with the device's latitude, longitude, and altitude every time the location is updated. The orientation sensor. The second type of sensor is the orientation sensor, which is also found in the sensor's palette. It is a non-visible component that allows you to determine the orientation of a device. It can determine tilts of the device, which are back and forth, left to right, and up and down. And it can also show the direction that the device is pointing, so north, south, east, and west in degrees. Now I will be discussing the orientation sensor's properties. First is the enabled property. The enabled property must be selected to allow the sensor to work. To do this, click on Orientation Sensor in the Components section, then select Enabled in the Properties section. You can also program it in the Blocks editor by setting the orientation sensor.enabled to true. Next is the available property. This property allows you to see if the device has an orientation sensor or not. App Inventor provides this read-only Boolean available property which will be true or false depending on the device's abilities. The main properties of this sensor are the roll, pitch, azimuth, magnitude, and angle. All these properties are read-only as their value is set by the orientation and movement of the device. The roll property indicates the amount of tilt left to right in degrees. If the device is lying flat, the roll is 0 degrees. When the device is tilted to the left side, the roll will be between 0 to 90 degrees, and if it's standing straight up on its left side, the roll is 90 degrees. On the other hand, if the device is tilted to the right side, the roll will be between 0 to negative 90 degrees, and if it's standing straight up on its right side, the roll is negative 90 degrees. The pitch property indicates the tilt of the device from the bottom edge to the top edge. If the device is lying flat, the pitch is 0. When the device is tilted so that the top edge is down and the bottom edge is lifted up, the pitch is between 0 to 90 degrees. And if the device is standing straight up on its top edge, the pitch is 90 degrees. On the other hand, if the device is tilted so that the bottom edge is down and the top is lifted up, the pitch will be between 0 to negative 90 degrees, and when the device is standing up on its bottom edge, the pitch is negative 90 degrees. The azimuth property indicates the direction of the phone in degrees. 0 degrees indicates it is pointing north, it will be 90 degrees if it's pointing east, 180 degrees if it's pointing south, and 270 degrees if it's pointing west. The magnitude property is used to determine how much the phone is being tilted in any direction. When the device is lying flat, the roll and pitch are 0 and the magnitude is also 0. As the degrees of the roll and pitch move away from 0 degrees toward 90 or negative 90 degrees, the magnitude increases. The magnitude will have a value between 0 and 1. A value of 0 is completely flat and a value of 1 is completely vertical. The angle property uses the roll and pitch values to determine what direction the device is being tilted. It returns a number that can be used to move objects in the tilted direction. The angle can be used to simulate an object rolling on a tilting table by knowing the direction to send it. The final component of this sensor is the orientation changed event handler. This event is called every time the device's orientation changes. The device sends the azimuth, pitch, and roll to the event handler as arguments, and these values can be used in the event. You can find these values by hovering your mouse over their parameter names after you add the event to the blocks editor. The accelerometer sensor. The third and final type of sensor is the accelerometer sensor, which is also found in the sensor's palette. It is a non-invisible component that detects whether the device is shaking or not, and it will report the acceleration of the shake in 3 dimensions, the x, y, and z accelerations. This sensor is used to perform actions when the device is being shaken. Now, I will be discussing the accelerometer sensor's properties. First is the enabled property. The enabled property must be selected to allow the sensor to work. To do this, click on the accelerometer sensor in the Components section, then select Enabled in the Properties section. You can also program this in the blocks editor by setting the accelerometer sensor.enabled to true. The sensor also has an available property that is set to true if the device has an accelerometer on it. The accelerometer sensor also has properties that return the acceleration values, the x-axis, y-axis, and z-axis. The x-axis property has a positive value when tilted to the right and a negative value when tilted to the left. The y-axis property has a positive value when the bottom of the device is tilted up and a negative value when the top of the device is tilted up. The z-axis property has a positive value when the device is lying on its back facing upwards and a negative value when the device is facing downwards. Next, there are two event handlers that are linked with the accelerometer sensor, the acceleration changed event and the shaking event. The acceleration changed event is executed when there is a change in the device's acceleration. The device will send the x-axis, y-axis, and z-axis arguments to this event and their parameters are updated every time there is a change. The shaking event is executed when there is a quick shake of the device. This allows programmers to program actions based on a shake of the device. The minimum interval property can be used to set the minimum time between shakes in milliseconds. For example, if an action is programmed based on the shake of a device, but you don't want to perform that action more than once per second, you can set the minimum interval to 1000 milliseconds, which is equal to 1 second. So if someone is shaking the device very fast, the action won't be executed more than you want it to. The activity starter. The activity starter is a non-visible component and can be found in the connectivity palette in the designer section. It can be used to launch other apps on the device from your App Inventor project. These apps can be those that are already on the device, such as the camera, email app, and Google Maps. The apps can also be ones that you have created or downloaded. An example of an app that you can use the activity starter component with is Google Maps. You can use this component in your App Inventor project and code it to open up Google Maps and have it zoom to the latitude and longitude of a location. You can also open up a more general location by knowing the zip code of the area that you want displayed. You can open a location by using an address as well, but it's easier to use a location sensor's geocoding because you would just need to get the latitude and longitude of an address and then use that to open up Google Maps to your desired location. Now, let's move on to the app tutorial where you can learn how to create an app using a location sensor. In this tutorial, I'll be showing you how to use the location sensor's properties to display the current location of the device. This app will show the latitude, longitude, altitude, accuracy, and address of the device's location. So first, we need to start a new project and we're going to name it Display Location. So now we can change screen 1 to have the name of the app. So now we need to design the screen. So we need 5 labels to show the latitude, longitude, altitude, accuracy, and address. So to get these labels, we need to go to the user interface palette and we're just going to drag 5 labels. So we'll go over here and change the first label and call it latitude label. The second one will be longitude label. The third will be altitude label. The fourth will be accuracy label. And the fifth will be the address label. So now we need to get the location sensor, which is located in the sensors palette, and it's right here. So we're going to drag the location sensor on. And we also need to change the text for each label. So we're just going to change the text to correspond it with the name of the label. So this will become latitude, colon. This one will become longitude, then this will be altitude, this one will be accuracy, and the final one will be address. So now we have our 5 labels and we have the location sensor. Under the properties section, we have a distance interval and a time interval. These intervals tell the device the minimum time or distance to wait before updating the location values. So let's change the time interval to 0 and the distance interval to 1. So this means that the location will update after the device has moved a minimum of 1 meters. So now that we're done with the screen, we're going to move on to the blocks editor. So first, we need to set the location sensor enabled to true to allow the sensor to work. To do this, we need to open the location sensor and select the set location sensor enabled block, which is right here, and we're going to drag it. And now we need to open the logic drawer and get the true block and attach it to the enabled block. So this means that this will allow the location sensor to work. Now we need to open the location sensor drawer again and select the location changed event handler. Now from the control center, we're going to select 3 if then else blocks. We can just duplicate it. So now we have 3. So we're going to take the first one and drag it into the event handler. And now we're going to open the location sensor drawer again and find the location sensor has longitude latitude property block. And we're going to plug it into this if then else block. The has longitude latitude block returns a Boolean value, so it is used to see if the device can report the longitude and latitude values of its location or not. So now we get a join block from the text drawer. And we're going to join together a string that says latitude. So we're going to use this text box to write latitude. And we're going to get the value of the latitude. So we can do that by hovering over the latitude parameter. And we're going to get the get latitude block, and we're going to drag in and attach it to the join block. And now we open the latitude label drawer and we get the set latitude label text and we attach it to the join block. Now we place it in underneath the then section of the if then else block. Now we repeat the exact same steps for the longitude. We get a join block from the text drawer. We get a text box from the text drawer. We're going to call this text box longitude. And we're going to get the longitude parameter. And we're going to drag the get longitude block and attach to the join block. And now we're going to get another set longitude label text block. And we're going to drag it and we're going to attach it to the join block, and we're going to put it right underneath the latitude blocks. Now we have to program the else section of the if then else block. So for this, we need a set latitude label text block and a set longitude label text block. So set latitude label and a set longitude label. And now we're going to need 2 join blocks. And we're going to need 4 text blocks that are attached to the join block. And now we attach the join block to the set latitude label text block and the second one to the longitude one. And so we're going to call the top one latitude. not available. And this one will be longitude not available. And we're going to drag these two into the else section. Now we're going to repeat the same steps for the altitude. So we're going to drag an if then else block into the event handler, and we're going to get a has altitude block from the location sensor drawer. And we're going to attach it to the if then else block. Now we need to get a set altitude text block. So we're going to go into the altitude label drawer and get the set altitude label text. And we're going to get a join block, and we're going to attach it to this block, and we're going to get one text block, and we're going to get the altitude parameter. And so we're going to call this altitude. And now we're going to drag this and put it in the then section of the if then else block. And now we need to fill in the else section. So we're going to get the same block again. So we're going to go back into the altitude label drawer and get the set altitude label text to block. And we're going to get a join block and attach it. And we're going to get two text box. And we're going to call this one altitude. And this one is going to be called not available. And we're going to drag this into the else section. Now we're going to repeat the same steps again to find the accuracy of the location. So we're going to drag the if then else block into the event handler, and we're going to get a has accuracy block from the location sensor drawer. And we're going to attach it to the if then else block. Now we're going to get a set accuracy label text block. So we're going to go into the accuracy label drawer and get a set accuracy label text block. And now we're going to get a join block from the text drawer and attach it to the set accuracy label text block. And we're going to get a text block, and we're going to call it accuracy. And we're going to get the accuracy block from the location sensor drawer, and we're going to attach it to the join block. And now we're going to put it in the then section. Now we need to fill in the else section of the third if then block. So we're going to go into the accuracy label drawer and get a set accuracy label text block, and then we're going to get a join text box from the text bin and attach it to the accuracy label. And then we're going to get two text box and attach them to the join. The top one will be called accuracy, and the bottom one will be called not available. Then we're going to add it into the else section. The final step is to display the address. So we're going to go into the address label drawer and get the set address label text box. Then we're going to attach the current address text box from the location sensor drawer, and we're going to attach it to the set address label text box. And then we're going to put it underneath the if then block. And we're going to move the set location sensor enabled true inside the location changed event handler. This is how the app looks once you've launched it onto your Android device. The values of the latitude, longitude, altitude, accuracy, and address will change as you move around. This clip shows the location values changing as I move around. Now I'm going to give you a recap of what this program will do. So first, we set the location sensor enabled to true so that the location sensor can actually work. Then, we added the location sensor location changed event handler, which will perform the actions inside when the location changes. In this event handler, we have an if-then statement that tells the device to check if it can report the longitude and latitude values. If it can report these values, then it will join a string that says latitude and the actual latitude value. And it will join a longitude string with the actual longitude value. And if it can't report either of these values, then it will simply say not available. The next if-then statement tells the device to check if it can report the altitude. If it can, then it will join a string that says altitude with the actual altitude value, and if not, it will simply say not available. The third if-then statement tells the device to check if it can report accuracy. If it can, then it will join a string that says accuracy with the actual accuracy value. If not, it will simply say not available. The last step that the device will perform is that it will show the current address of the device's location. Here is another look at the designer section of the display location app. It has 5 labels: the latitude, longitude, altitude, accuracy, and address label. It also has a location sensor that is set at a distance interval of 1 meter and a time interval that is set at 0. This is how the final blocks editor section looks. In this video, you have learned a lot about Chapter 12 of the Starting Out with App Inventor for Android textbook. As I've discussed, the chapter focuses on 3 different types of sensors that are found in Android devices. The functions of the sensors are described using their properties. The 3 types of sensors are the location sensor, which determines the device's physical location, the orientation sensor, which determines the device's orientation in 3D space, and the accelerometer sensor, which determines the device's acceleration in 3D space. I have also discussed the properties of each sensor and how they support the sensors to execute different programs that we create and use. I hope this video has given you a much better understanding of the use and components of sensors.